So I'm going to go a little bit more technical on your asses than Christopher did, but I'm trying to. I'll try to also go easy on you. So you know, we're going to talk about space resources. Christopher has mentioned a lot of this stuff already, but hopefully it'll expand a little bit upon what he said. So yeah, in situ and general utilization. In situ would be using it where you are. Just general would be using it wherever. So kind of two parts here. Okay, that's me in black and white. I'm the CEO and co-founder of Solstice Mining, which is my company, my startup. I'm also the lead design engineer at Replay Aerospace, so that's how I know Christopher. My day job is as a mining equipment R&D and comminution product design specialist or engineer kind of guy. Really long description there. My background is mechatronic systems engineering, and I also have the SSP program from the International Space University. And it's kind of weird that 3 of the 4 speakers have that, so that's cool. So if any one of you is interested in space, then you should check out the ISU for sure. Yeah, so you know, you can ask me for my phone number and home address and whatever later if you want to. Okay, so Christopher, thank you by the way for talking about the colonization or recolonization of the US or the Americas. So I wanted to imagine what it would be like if everything that they used in the Americas during the colonization was brought in by boats and by ships, right? So they couldn't use any of the stuff that was available in the Americas. They had to get everything shipped to them from Europe, right? That's basically what we're doing in space now. And it's quite unsustainable, I'd say. It's not gonna, it's too costly and it's too cumbersome. It's never gonna, you know, explode into any sort of space infrastructure or space economy or anything. What we need to do is find stuff in space that we can use in space. At least that's my opinion. So yeah, space resources, they're an enabling technology for a proper space economy and infrastructure, as I said, and also the democratization of space. It'll lower the cost drastically, right? Yeah, we'll come back to the Mars exploration stuff as well. So where do we find these fancy space resources? Well, they aren't further away than 160 to 2,000 kilometers, which is low Earth orbit. That's where most of our let's say Earth observation satellites are, stuff like that. We also have some in medium Earth orbit and also in geostationary Earth orbit. And a very interesting orbit here is called the graveyard orbit, which is where they push these big geostationary satellites to when they're at end of life, right? So it's conceivable that we can actually go out there with the right technology and pick apart the satellites and use the resources there to build new stuff. So either use the components in the satellites as they are, or grind it down to, you know, powder and print with it or something. The cool thing about this is that this technology is also the same technology that would allow us to, you know, refuel our satellites and so on, make them last longer. But it has another use in where like an evil empire could go up and grab a nice empire satellite and deorbit it, right? Or crush it or something. So there's this dual use issue in most of the things we do in space actually. This picture here is from, it's simulated space debris hit. So space debris is all the crap floating around outside the Earth, which is stuff we would very much like to recycle or at least get rid of. And this is also something we would look into with the Earth orbit space resources. But as you can see, it's quite dangerous. This is a aluminium pellet fired at I think it's a 15 centimeter aluminium block at about 7.7 kilometers per second. So this would destroy like any satellite you put out there if like this 1 10-gram ball hit anything. A paint flake is deadly in space, actually. All right, this one, the big neglected ball, the moon. We've been there before, you know, we know how to do this stuff. It's quite close. We're actually really lucky to have such a platform as the moon this close. We can practice going to Mars, practice all these, develop these technologies just a few days from Earth. And there are, as I've written here, likely hidden treasures on the poles and in impact craters. And the treasures we're talking about then is water, because water can be split into hydrogen and oxygen, and that's propellant, right? So we could actually refuel our spacecraft on the moon or in orbit around the moon and go to Mars, which would make it simpler, likely. Yeah, so this is just an overview of some of the resources we might find on the moon. You know, you have magnesium, iron, titanium, silicon, oxygen, like it's all over the place. So yeah, this is quite interesting. I think this image is like fantastic, but you guys probably think it's silly. I don't know. Yeah. Yeah, so when we're talking about the moon and the moon resources, we're talking about regolith, which is this powdered mixed particle size stuff, which is littered all over the moon. This here is a good picture of it. Here you can see this regolith stuff, rocks and, you know, powdered things, tracks. This is from the Jade Rabbit, or U2, which is a Chinese rover. The reason I have it here is, of course, because I'm the killer rabbit, as you all remember, right? And this survived for 42 days on the lunar surface. So rest in peace, poor U2, Jade Rabbit. Chinese probe, as I said, and it's the last one we sent there to the surface of the moon, as far as I remember. So yeah. But this is, as we call it, the raisin in the sausage, right? This is the cool stuff. So you guys just saw this one orbiting over us, right? About 80 meters in like solar panel span. And this is Itokawa, an asteroid which was visited by Hayabusa, a Japanese probe in 2003 or 4, I think. About 540 meters. So these asteroids of all different sizes and types and shapes, they're located basically in 3 areas. So we have the Earth crossing ones, or the near-Earth asteroids. These are the ones that could be dangerous. You know, dinosaurs didn't have a space program, that's why they died and so on. Main belt asteroids, those are the... By the way, does anyone know, can anyone list the planets for me from the sun and out? Anyone?
Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune.
Perfect. Okay. Good. Really awesome. So the reason I'm asking is, does anyone watch The Expanse, by the way? Yes, this is the cool stuff, right? So the Ceres, the big space rock that they live in The Expanse, is actually a dwarf planet which is located in the main belt, and the main belt is located itself in between Mars and Jupiter. So this is like a big belt of asteroids, right? It's not like you see on Star Wars movies where the asteroids are like crashing into each other and they're all over the place, like millions of miles apart. But there are a lot of them there, like millions, probably billions of them. And then we have the Jupiter resonant asteroids, which are the Trojans, Greeks, and the Hildas. I don't know what happened with Hildas. The other ones here sound kind of cool, but this is like, yeah, Hildas. Yeah. And the asteroids are, they're divided into MS and C classes. This is asteroid Ryugu. Hayabusa 2 is orbiting this asteroid as we speak, and it's getting closer and closer, and it's going to land and grab like a small sample and take it back to Earth. I don't remember what kind of type or what type this is, but let's just go quickly through these 3 once. So the M type is a metallic asteroid. That's where we have all the gold and the platinum and all those fancy things. The S type is a stony or silicaceous asteroid. Not really too interesting, I'd say. It's like a rock, you know. Although everything is useful in space. Every pound you put up there or every kilogram you put up there is equal to the price of putting a kilogram into space, which is, how much is it, Christopher? Like $5,000? Yeah, so, yeah, okay, cool. And then you have the C type, which is the most interesting one. Those are the ones that also contain water, like the moon in certain areas. So if we can go to one of these asteroids, we can refuel our spacecraft, go to another asteroid, refuel, and so on and so forth. Or we could actually, like some people are planning, to find an asteroid which is about maybe 50 to 20 meters in diameter, put a large bag over the entire asteroid, and pull the asteroid into Earth orbit where we can mine it. So they want to use the oxygen and hydrogen on the asteroid to pull it into Earth orbit, right? So they use it as propellant on the way. Okay. Oh, shit. So this is an overview which I think is really cool. So now you remember this one, Itokawa and Ryugu, right? So this is Ryugu here, and this is Itokawa, right? So they're really tiny, tiny asteroids, and I'll tell you the estimated value of Ryugu in a short while, which is just mind-blowing. But they, as I said, they come in all shapes and sizes. And here, if some of you remember, the Churyumov-Gerasimenko 67P comet, which Rosetta landed on, and Philae, did anyone see that? It's like completely crazy. That's this one here. So not a big piece of space resource, that one either. Yeah, all right. So how do we get at these resources? How do we pull them out? How do we use them? So this is like, nope, we don't bring an excavator to the moon. That won't work. Neither will this. Bring one of those, you know, the big German style things and dig from the moon. But basically, this is the area where the research is right now. They have some prototypes of machinery that can dig out stuff from the moon surface or from asteroid surfaces, but there are some issues which we really need to solve before this is feasible. So yeah, so when we get at these resources, which I will talk a little bit more about later, what can we use them for? So typically building stuff in space, 3D printing, right? That is something that's been mentioned several times already. We can make huge mirrors for telescopes. We can make habitats or like big things like this one, which is a space station for, I think, 140 people. With those Bigelow modules that Christopher talked about earlier, inflatable ones. Or we can use them for propellant, as I've said already. And also we can mine the valuable minerals and then take them back to Earth. At least that's the kind of the plan, right? So yeah, I'm really proud of this one here. I made this picture myself with the joint and the glasses and everything. with paint, you know? I'm like the master of paint. So the asteroid I showed you, the like tiny one, not the tiniest tiny one, but the like almost tiniest one, is worth around $80 billion, right? That's the estimated value, $80 billion. The profit, they say, is around 30 billion. So not as much, but still it's an okay haul. And then you have several hundreds of asteroids that are valued to over $100 trillion a piece. Okay? That's like mind-blowing. And you probably have the same on the moon, and you know, you can save probably almost the same amount by utilizing these fueling depots and so on that I talked about. So yeah, and then you know, you can say the same for the recycling these different resources in Earth orbit as well, but the values aren't as high there. The value is definitely in the asteroids and stuff like that. So, as was also mentioned earlier, there is a small point about ownership and the Moon Treaty and the Outer Space Treaty. So we don't really know who owns the stuff if you actually extract it. All right, yeah, I was supposed to say something here which was really smart, but I forgot it. Yeah, okay, we'll just jump on. So anyway, extremely interesting area and extremely profitable if we pull it off. But if you take these minerals and metals back to Earth, you will crash the economy completely. So very likely we will use them in space, build a space economy and a space infrastructure for going further out. So this is my company. We are a company located in Oslo. I have people from around Europe and a guy in the US as well. And we are trying to grab as much of the technology we already have from the terrestrial or the Earth mining sector and spin it into the space sector. Okay, so this isn't a trivial matter. I have to explain just briefly how the terrestrial mining sector works, and that is they start by blasting something out of a hole or an open pit mine or a shaft. They crush it and grind it down to a really small particle size. You get to a place called economic liberation. That's when you can take your copper pieces or your silver pieces or whatever out from and separate them from the rocks, right? And that is done by using water and different solvents and things like this. So the last step after the water processes is melting this into, for example, like a gold bar or an iron ingot. Okay, really like a brief explanation. So this is a typical piece of mining equipment. It is a grinding mill that grinds material down to super small sizes, and this one weighs in at 1,100 tons. And Christopher can tell you that that is a very expensive launch. We won't be able to put that on the moon, ever. So we need to find out how to miniaturize this, and also we need to find out, because this one works by throwing these steel balls around with the ore to crush the ore down to this economic liberation, and that requires gravity, right? And it requires atmosphere. So we can just throw water, gravity, atmosphere out the window, and then almost start from scratch in designing technology that can do part of this terrestrial type mining process on the moon. So I think I'm just going to jump over this next stuff here. The potential applications that we're seeing for this technology that we're working on is, for example, 3D printing, contour crafting, or just, you know, regular materials extraction. So we're trying to facilitate and create these small function blocks that the bigger the astro mining companies can put together and do their own missions. All right? Yes, that's what we're doing. And that's all. Thanks.